Could Mercury's close orbit around the Sun help the planet generate ice? It sounds like a paradox, but new analysis of the planet's surface chemistry suggests that heat-generated ice may indeed be the case. Even though daytime temperatures on Mercury soar to 750 degrees Fahrenheit, 400 degrees Celsius, ice can occur in craters sheltered from the Sun. There, the surface is exposed to cold space at about -330 F, -200 C. Explanation for how some of the ice got there, chemically speaking, remains under investigation. A new study shows how water can collect on the surface even amid these extremely hot temperatures. The minerals on Mercury's surface contain groups of bonded oxygen and hydrogen atoms known as hydroxyls. Protons from the solar wind, the constant stream of charged particles from the Sun, are common on the planet's surface, since there is not enough of a magnetic field to repel the particles. This study's model suggests that the magnetic field can cause protons to migrate across Mercury, so the protons can then implant themselves in the soil and the hydroxyl groups. The Sun's searing heat energizes the hydroxyl groups, causing them to crash into each other. These collisions create water, as well as freeing up extra hydrogen that leaves the surface and drifts above Mercury. As for the water molecules, some of them get broken down by sunlight and dissolve into their elemental components. Other water molecules escape from the surface and fly into space. However, a few water molecules escape these fates and instead land on the poles of Mercury, making it into permanently shadowed craters. And there, the molecules can stay, since Mercury has no substantial atmosphere that would further affect the water molecules by conducting heat, for example. While this sounds like a subtle process, over time, the water ice would add up. The model suggests that in 3 million years, Mercury would accumulate 11 trillion tons, nearly 10 trillion metric tons, of water ice, which is roughly 10% of the observed ice on the planet. Other ice may have arrived from small worlds such as asteroids, comets, and meteorites.